Dogs are these intelligent creatures, but yet there's a limit to what they can understand. And we think that they don't understand, for instance, the general theory of relativity. And every time I say that, I always think maybe the dogs are out there that they think we don't understand general relativity. But assuming that's not the case, here we have a very good example of smart beings that are limited in what they can understand. So why is it that we aren't in the same boat? And presumably we are in the same boat. So I think that's a given, that we may be limited in what we can understand. But to the specifics of your question, why is it that we think we're making progress? It's very straightforward. We can sit down with the equations of quantum electrodynamics and calculate properties of electrons, their magnetic properties. The details don't really matter, but the calculation agrees with the measurement decimal by decimal by decimal 10 places after the decimal point.
Right.
That's enough. I'm done. I mean, think about that. That is an astonishing fact, that these strange gloppy things inside of our head can figure out the mathematics to understand the property of a particle to 1 part in a billion. And it agrees with the measurement. And at that point, you say to yourself, for some reason that we can't quite understand, mathematics provides this powerful illumination into the dark qualities of the universe and allows us to make progress on questions that don't seem to have any relevance to survival, right? But yet somehow the brain has gotten to the point where it can figure these things out. And it's not just they don't have relevance to survival. One imagines that back on the savannah, those of our forebears who got caught up thinking about black holes and quantum physics, they got eaten, right? Yeah. So it's like not good for us to do this, but yet somehow we're able to.
Yeah, well, we have the last scene that we know about where that was almost certainly true was Archimedes in his bathtub.
Yeah, that's a curious one.
Making some more breakthrough in geometry, and then a Roman soldier just came in and impaled him. So, first rule of self-defense, you stop with the math when someone kicks down your door. So I just want to revisit some of the points you just made there, because so people have made, I've been a consumer of skeptical utterances on this very topic. So I think there was one popular book on physics I read years ago. I think it was probably a John Gribben book, and it was. He said in there that there's a famous paper by Wigner, I believe, The Unreasonable Effectiveness of Mathematics in the Natural Sciences, or something close to that title.
Yeah, that's right.
And so it's been pitched as this mystery that mathematics seems to map onto reality in a way that is surprising and counterintuitive, and we're still just trying to make sense of that. But I think it was Gribben who wrote that actually the idea that mathematics that it's surprising that mathematics maps onto reality is a little bit like saying it's surprising that the English language is so good for writing plays in. Right, that there's this is the thing we're using, and we're finding ways to fit it to the circumstance we're in. That is, it seems to me that there may be a serious disanalogy there, in that mathematics, unlike English, seems to make predictions about what should be so. I mean, the relationship between electricity and magnetism, say, which then can be tested and proven to be true, that the mathematics itself sort of shines a light in a direction we weren't necessarily looking.
Right.
Is that valid, but is there more to it than that?
I don't think there's more to it than that, but that's a breathtaking quality, right? I mean, the fact that you use English to articulate thoughts and describe situations, sure, that's the mode that we have developed for that kind of communication. But mathematics is not a natural language, right? Mathematics is a way that we have found of encapsulating pattern in the world, but yet when we have identified the pattern, we can then use it to go far beyond the context in which it was developed. So, Einstein is thinking about space and time and the special theory of relativity in 1905, 1906, 1907. Then he takes this mathematics off the shelf in about 1912, a body of mathematics called Riemannian geometry that was largely developed in an abstract realm of mathematics to describe curved shapes, the kind of thing that the idle mathematical mind might find interesting, but not because we were trying to describe the external world. He takes that mathematics, is able to work with it into this generalized version of relativity, the general theory of relativity, and then make predictions about how stars in the distant night sky should look when their light traverses near the sun. And the way that those positions of the stars shift is then borne out by photographs taken 4 years later during a solar eclipse when the stars become visible.
Yeah.
That's the craziness, right? He wasn't trying to describe the motion and the position shifting of those stars, and yet he was able to make a statement about something that he had never received any data on, and it agreed with subsequent measurements.
Right.
That's the part that is absolutely thrilling.
So there are physicists and mathematicians that have a quasi-mystical, quasi-Platonic notion about the significance of all this. So what's your explanation, if you have one, for why math seems to reach into the darker corners of reality for us?
I sort of look at it two ways, and it kind of depends on how a given day is going, when you're doing the calculations. I mean, sometimes it feels like you're just sort of chipping away at the stone, revealing the beautiful sculpture, as if it's already out there and all you're doing is revealing it. Other days when it's not going so well, it just feels like you're desperately trying to invent the ideas in order to be able to make progress. So I kind of go back and forth between the two, I have to say. I don't have a consistent view of the role of mathematics in this regard. And I would even say there are times when I don't know if worried is the right word, but I've imagined the possibility that one day we make contact with an alien civilization and they say, hey, show us what you guys have figured out. And we bring out the textbooks with all of our beautiful equations, and they kind of look at it and they go, math.
They put you in a video where you're the dog.
Yeah, right. They basically, exactly. They basically say, we tried that for a while. It's kind of a dead end, guys. It'll take you just so far.
Yeah.
But then the funny thing is, if I try to imagine what they would replace it with, I can't even think of what they would replace it with that isn't in some sense mathematics, perhaps in an unrecognizable form or an unfamiliar form, perhaps a better way of saying it, because if math is the language of pattern, what are we doing? We're all just trying to encapsulate patterns. So whatever language you use to do that, maybe that is what math ultimately should be described as, and therefore will always be back to this kind of structure.